Howdy folks. So today I thought we would take a look at a kitchen gadget of mine, which I've had for a couple months, and I have yet to take it apart, but I think it's about time to do so. This is the Anova precision cooker, and if you're wondering why I'm holding it kind of in a strange way, it's because I've already taken all the fasteners out of this thing. I wasn't quite sure how to get into it, so I kind of took it apart already, just so that I could actually make sure I could take it apart without destroying it. So I didn't want to put it all back together again just to take it all apart again. It didn't make a lot of sense. But I did want to show you what it looks like when it's fully assembled. So this is a sous vide cooker. So basically, the way that this works is there's a clamp that goes around this, and you hook this onto the side of a big pot filled with water, and you put your food, like your meat, in a vacuum sealed bag or in just a Ziploc bag, and you just use water displacement to get the air out. The idea is, sous vide means in vacuum. The idea is you put the food in a vacuum, in a bag, submerge that under water, and then this has a heater in it and a pump which recirculates water at a particular temperature for a particular amount of time, and that cooks the food, and then you sear it afterwards. And it's got a little display up here with the temperature, and there's a little rotary encoder which you can set the temperature with. And this thing is primarily designed to be used actually with a cell phone app. So this particular product comes in two models. There's a Bluetooth version, and there is a Bluetooth and Wi-Fi version, which is the slightly higher end model. This is actually the higher end model. It has both Wi-Fi and Bluetooth. I didn't really need the Wi-Fi, but they didn't have the other model in stock, and it was a good sale, so that's when I bought this. I wouldn't recommend buying this on regular price. It seems way too expensive, but they have sales every so often where it pretty much halves in price, and at that point I think it is reasonable, especially after I've seen inside of this, just some quick glances. It does appear to be well made, but I'm going to look into that a little bit more detail. So this has been used. I've had this for a couple months, 7 months or so now, I believe. So it is well used. As you can see, the water I have in my area is pretty terrible, and even with cleaning, everything looks like this eventually. But the thing is, this is fine because the water that this recirculates never actually comes in contact with the food, so it's not that big of a deal. So it's just got this little cover on here, which is it's got some plastic for directing the water flow, because it's got this little impeller here with a big shaft that runs up. Of course, the motor's up here. The motor's not submerged. There's no waterproofing in this device at all, so if you get it wet, it's fucked, pretty much. And of course, there's nothing very exciting in this. I mean, and I knew that going into the teardown. Really, I was more interested in the systems design. Basically, how did they get everything into this package, and how did they how did they design it for the envelope? The systems engineering is more interesting. So there's going to be a motor in here, a switch mode power supply for the low voltage stuff. There's going to be digital boards up here. Of course, it's going to have the Wi-Fi, Bluetooth modules. We'll see if they're modules or if they've actually done it themselves. And just all that kind of envelope design is really what's more interesting in this. So to open this, if you wish to do that yourself, there's two screws down here, down these little holes, and these holes contain screws for the motor. And you technically don't need to take those out to get it open, but I took them out anyway because I wasn't quite sure. There's nothing under the label on the back here, but you will have to take the label off to get this open. There's two screws here, and then you're going to have to apply an unreasonable amount of force between these two halves. You can see the seam here. This actually does come apart with just two screws. It doesn't appear like it does, but it does. There are clips here, and they're very strong, and I really did think I was going to break it when I tried to open it. That's why I wasn't quite sure, because I was trying to find something over here. And then it splits into several pieces, all of which are going to fall apart as soon as I let go of it. Okay, so after some serious prying, I've gotten the case open, as you can see. And of course, if you haven't already taken it apart, you'll have this sort of head unit attached, and there's just two screws here, and then this thing lifts off. There's just a ribbon cable you have to detach, and it comes aside. And so that's all the electronics, and we're going to come back to that. This is more of the power electronics, which we'll look at first. So the mains comes in here. There is a kind of a strain relief. It's just a clamp that they've got here. There's no external strain relief, but it looks perfectly fine to me. They've got fiberglass sleeving over the mains leads, and then they've got a ground which comes down to the motor itself. And I've removed those screws, so the motor itself is actually loose. You can see the shaft moves. And the way I think that they assemble this is they've got the little impeller here, and there's just a screw on the end of this. So I think what they do is they put the motor in the plastic first, they slide it through, then they stick the impeller on the end, and then this board goes on last. And this board is what appears to be the power supply. Of course, it's the power supply, but it also appears to do the temperature sensing and heater regulation. So here, of course, we've got the heater, right? It's just a standard coil heater and comes back here. And there's 3 temperature sensors in this. There's this one here, which is kind of high up. There's this one here, which is further down. It goes all the way to the bottom of the coil. And then there's this one, which is actually hose clamped to the heater itself. So it's got 3 thermal reference points. And I don't really know if these are thermocouples or thermistors. I would hope that they're thermocouples, but I really don't know. And there's really no way for me to tell. So I don't know what they are, but I wonder. I've actually never calibrated this. I don't actually know how accurate it is, but I do have a really accurate lab thermometer. I could calibrate this against if I really cared, but I'm a little lazy, so maybe not today. There's quite a bit of wiring on this, so I think I'm just gonna kind of leave it like this. So we've got obviously our power supply, nothing super exciting. Common mode choke. It does have a fuse, which is good, and not user replaceable, of course, because we're never supposed to get this far. We have a relay, which is what I would suspect they're using for controlling the heating element, switching it on and off, because this is an 7 or 800 watt. Let me see. 800 watt. Yeah, it's an 800 watt unit. So I suspect that they're not using a transistor or something to do that switching. So it's probably what this relay is for. This connector is for the ribbon, which leads to the digital board. So that would be for basic control and of course for supplying the low voltage power up there. We have what looks like a switch mode module. You'll notice it's mounted off board. So there's a stake here and a stake on the other side. There's 1, 2, 3, possibly 4 stakes on that. So this could be just an off-the-shelf power supply module. I don't recognize cap brand on this. I mean, it's just kind of your regular cheap switch mode supply module. And then there's this big heatsink device, which I originally thought was actually part of the switch mode power supply, but upon second look, it doesn't actually seem that way. It might be that they're just using this little power supply to output 5 or 12 volts. It's got a 16 volt output cap, so it could be either probably a 12 volt supply, be my guess. They might be using just this to give them, they only need probably a couple hundred milliamps to run the electronics. So this might actually be a solid state relay or just a really big FET, and they might be using this to control the pump or the heater. In fact, this actually might be used to control the heater, and this might actually be used to control the pump, because the pump is always on. I'm trying to remember. Last time I used this was a couple months ago. Actually, you know what? I think that's probably the case. This is probably for the pump, because the pump switches on when you turn the unit on and switches off when you stop cooking, but the pump is always on regardless. And so this would attribute the clicking to that, but there's no clicking when the thing's running as the heater cycles, which means the heater is probably on a solid state relay, which is probably what this heatsink device is here. And it has nothing to do with the power supply at all. So yeah, okay, that makes a lot more sense. And then there's this board, which is also appears to be kind of custom, and this is where all of the thermal sensors are going. So this would be the temperature regulation board. And we've got these, I'm not entirely sure what these are. They look like two metal plates, and I don't really want to play with them in case they relate to calibration in some way. But I don't know much about how these temperature sensors work, so there may be something that they're doing. If these are made of different metals and they're using like junction temperatures or something to get a reference for the other temperature sensors. That would maybe be my guess. They don't look like current shunts or anything like that, so that's what my guess is. But I don't deal with temperature sensors very often, so I'm not quite sure how they actually get the reference point. But on here, I just expect some op amps and just maybe some comparators and things. There is an opto here, which is a little interesting. So yeah, this would just be your temperature regulation board. I'm not sure if it actually does if there's like a closed loop feedback system on this board in the analog domain, or if they simply feed back some analog signal through this connector to the digital board, and the digital board actually does the heater on-off control through this. I really don't know, and there's just a smaller transistor here. God knows what that's for. And on the bottom, nothing majorly exciting. You can see that they've slotted that board through and soldered it on that side, so it's actually pretty structurally sound, which I like. There's a current shunt there, pretty obviously a current shunt. And yeah, nothing else super exciting. Date code 48th week 2015. So I bought this in, I think, August of 2016. So it's been sitting on a shelf for a while, or had been sitting on a shelf for quite a while, which might explain the massive sale that they had. I don't know how many of these they sell. Okay, so I just realized that the bottom comes off, which would have been really nice to know a few minutes ago. But anyway, so here's our motor. It's just some standard AC motor, nothing special about that. 120 volts AC, 60 hertz. Doesn't really give a current rating, doesn't really matter. I took this screw out as well when I was disassembling it. I wonder if that goes through, if that's for grounding purposes. Yes, it is. Okay. Because I saw this ground terminal flapping around, and it's just because I had loosened this screw when I was trying to figure out how to remove the bottom of this. But so obviously they've got ground, goes to the motor, and it also goes over to the thermal probes, and it all goes to that screw, which then grounds the heater. So this is all grounded through that, which is a pretty good mechanical connection. They've crimped everything on. I'm okay with that. They have put a bit of sealant here. This is that kind of hard silicone type stuff. So they have tried to seal, from water ingress here, because obviously if you wash this, you can't prevent any water from wicking up through here. So they've done a good job there. And as for what kind of bearing, there's no bearing here, as far as I can tell. They've just kind of slopped some grease in there. There isn't a bearing in this, so you can see it just moves around. It's just kind of a hole. So the bearing is part of the front of the motor assembly. There's nothing that contacts that shaft when this is screwed in permanently. So that's it for this. I mean, really isn't that much else to see. It's a power supply and some thermal stuff, and oh god, it's getting stuff all over my desk. The water is so hard where I live, it's ridiculous. So anyway, moving on to the more embedded electronics-y type stuff. This is the sort of the head unit. This is the brain box. And one thing I'll mention is the whole bloody thing is that soft touch butylene rubber compound, which I really hate. It generally just gets all dirty and nasty, and it disintegrates over time. So keep that in mind if you buy that. It feels nice, looks really nice, but not sure how it will last. Because cleaning this is kind of annoying. Anyway, so this is the rotary encoder, which is just screwed in with two screws, and it just kind of pops out, and it's got a ribbon cable for it. There's nothing really exciting to say about this. It's just a little tiny rotary encoder with a knob. You can't push it. It's not like it's not like an optical mouse where you can push it, or just a mouse, laser mouse. I don't know why I said optical mouse. It's literally just for setting the temperature. It provides sort of like the minimal amount of user interface that you need in order to use it if you don't have a phone. So like it's really designed for use with a phone, but this is just one of those, I can make a quick adjustment without it. And it's got some residue on there from soldering, so clearly they didn't really clean that up. And so when I saw this, I was kind of disappointed because of course you can see the back end of some screws, but there's no heads of screws, which means you've got to go in through the front. And I managed to actually not completely tear this thing to shit getting this front off, because of course this was just going to be glued in or taped in, and it was taped in, which was nice. So I just kind of put it in an offset so that I can get my fingers under and pull it off. So you can see it's just got a ring of adhesive tape around there. So you can get that off without completely destroying it. And at this point, this silver part is held on by 4 screws, which you can take out. And so we can start to see the beginnings of this of the assembly. So this would be the temperature display, and this would be the timer display. And they've actually taken off the plastic. There's no clear plastic on front of these displays, which surprisingly enough, most things I see that have 7-segment displays inside stuff, like with a cover on it, never bothered to remove the protective film. So the fact that they removed it, I'm actually pretty, I think that's a good thing. I mean, I shouldn't congratulate people for removing protective film, but most companies just don't bother with it. The buzzer, I believe, is underneath here. And I thought this front actually came off, but no, it actually removes the back piece. And it's got 2 ribbon cables, of course, one for the power and one for the rotary encoder. And I was met with the first surprise. Of course, we've got our board stack over here, but there's a fan in this thing, which I did not know about until I opened it. And the reason is because when you plug it in, you don't hear anything. But of course, when you turn it on, when it actually starts the pump up, of course, it starts to make noise because the pump makes noise. But obviously, when the pump comes on, it also starts up this fan. And I thought that was kind of odd because, as we'll see in a moment, there's nothing in this that would produce enough heat to warrant this fan. And you can see they've went to a pretty great deal of effort for this fan. I mean, they've actually sealed the air duct on this thing. Basically, it's sealed on all 4 sides, so it sucks air in from the top, which is where the circuit boards are, and then it actually exhausts it through this channel down here. So there's nothing below here that needs to get cooled. It just exhausts the air. Obviously, it comes in through this vent over the electronics down through here and into the power supply area. And I think the reason for this is basically, when the thing's operating, of course, the power supply is going to produce heat at the bottom. It's going to be, it's under here. It's going to produce heat. The pump, the motor is going to produce heat as well. So it may rise up, and maybe they want to force air down to prevent it from, sitting in the cavity where all the electronics are. But I think the other reason is, of course, this thing is going to be sitting in a pot of water, which is going to be, potentially just under boiling. So it's going to have a lot of water vapor coming up, like steam, and it's going to be hot. So the ambient air temperature in this cavity could get, perceivably quite high. So they may just be using this fan to maybe push the water vapor out, just to ensure that no air sits in this for too long, maybe to prevent water from condensing on the electronics. I'm not entirely sure why they had to do this, but I was very surprised to see this because, I would have never known that it was in here. And they've soldered that on, unfortunately, so I can't just remove that. I'm just going to leave that the way it is. In fact, they've actually soldered everything together on this. And, there are so many boards on this thing. If we want to count, there's 1 board, 2, 3, 4, 5 boards that make up the electronics in this thing. So unfortunately, they've soldered all of these boards together. They've got little 0.1-inch headers on every single board, and they're all soldered. So I really don't want to take these connectors off to get this apart, just to read some chip numbers. The most important chip number I can still read without taking the boards off, so I think that's going to be sufficient. The bottom board is pretty obviously just the display board, so it's going to have the, of course, it's got the 7-segment displays and the beeper on it, and we can actually see, if we come around to this side, there's a chip right here. It's in a little dip package. That chip there is most certainly the 7-segment display driver, because it's the only big chip that's on that board at all. So no real surprises there. The second board, of course, is the main processor board. So we've got some inductors, so there's obviously some power supply stuff going on here. And our main processor is under here. And I'll get back to that in just a moment. Then we've got our comms board, which is the board on top. This is 39th week 2015. So again, it's been sitting for a while. And we've got our 2 modules here. So this would obviously be our Wi-Fi module, and this would be our Bluetooth module. And one thing that really pissed me off when I got this thing was I had to put this thing on my Wi-Fi network, and I have MAC filtered networking, and this thing does not have any. Basically, the MAC address is not visible on the product. It's not. There's no sticker on the device or anything that tells you what the MAC address is. So you have to actually connect it to another network to determine the MAC address and then configure it for the real network, which is what I had to do. It took me a long time to get this thing on my network. I was very upset about it, and that's basically the official help page. So the MAC is literally printed right here. I mean, you're telling me you can't just copy that and stick it on the sticker on the outside? I mean, that was a little touch that just really irked me. So that's a pretty much dead giveaway as to what that is. And of course, they didn't design these. These are just off-the-shelf modules. I mean, no one really bothers to design these unless you're making an incredibly cheap product. Just buy them, and they've got probably a SPI interface. Given by the number of pins, there's probably a SPI or I2C interface to these. They don't look to be USB. In fact, I can guarantee you that they're not USB. They're definitely a simple protocol. Obviously, we've got an inboard antenna here for the Bluetooth, but the Wi-Fi, you can't really see an antenna on this side. It might be on the other side of the board, but yeah, I can't quite see where the antenna is for that one. There is an LED on it, interestingly enough, so I wonder if we could see that when it's running. I never bothered to look through the vents. So, of course, everyone wants to know part numbers. So what I'm calling the Bluetooth CC2541. So I'll look up what that one is. There's a shield on the wireless module, unfortunately. So, and it is soldered on. So I don't really care, to be honest. It's just a wireless card. So I'm not going to bother to find out what that is. But one thing I really did want to know, though, was what was the main processor? What microcontroller did they pick for this thing? And of course, it's under here, but I was able to, using some optical voodoo, I was able to read it. And interestingly enough, this is an IAP branded Intel 8051 core microcontroller. And I had a hard time finding any data on this thing. And I'll insert some pictures. I went to a website called stcmcu.com, and you get this giant picture. Like, the whole website is just a giant picture. And it's all in obviously some Chinese that I can't read. And of course, because it's an image, Google Translate's not going to help you there. So, and it looks like a big table, and so I got the part number off of this, and so I scrolled down the table, and I was able to actually find a row in that table which corresponds with the part number, and I was able to read off some of the data for this chip, and so it appears to have, if I remember correctly, 61K of ROM, 4K of RAM, and it's got some PWM, some A to D, some capture control, just sort of basic stuff in there, and it runs somewhere. It's pretty much a 3.3 or a 5 volt device. You can run it at either voltage, so I'm not quite sure what they're actually using on this. Probably, I would suspect maybe 5 volts, just because a lot of these modules run at 5 volts, but it could be 3.3 because they're not USB modules, so who really knows? But yeah, clearly they've designed all the boards themselves, other than these modules. I mean, the power supply. And all this. This is all designed. I mean, because it's round. It's got to fit in this this enclosure, and so they've decided that stacking boards like this is the best way to do it, to get it in the volume that they have. I'm surprised that they have as many boards as they do. I mean, there appears to be a lot of empty space on this bottom board, and you know, honestly, I feel like you honestly could have probably got this onto just 2 boards. If you'd made 2 boards about this size, you could probably have done it in 2 boards, and maybe hang these off the edge. But they decided that you know, 3 was the best way to do it, and I'm not quite sure why, but they look like I can't quite tell how many layers they are. They're either 2 or 4 layer. I would really highly doubt that they're any more than 3 or 4 layers each. And one thing that's kind of interesting, of course, is this is the high-end model. So this has the Wi-Fi and the Bluetooth. And what I'd really love to know is what can you do with the Bluetooth only model? So if you had the Bluetooth only model, of course, you're going to have the same board probably, and this is probably just not going to be populated. It's very possible that this entire board, this entire assembly, they actually have a separate version that's half the size and it just has this on it, and there's no footprint for this. But that seems a little bit too much effort for me. My suspicion is that probably it's the same board, this is just not populated. And I wonder what would happen if you knew what this was and you just put this in, you solder this in yourself. Would that give you the Wi-Fi capabilities? Because it would basically depend on whether this unit has the same firmware as the Bluetooth only model. Because they could do it one of 2 ways, at least that's the way I would do it. Either you have 2 separate firmwares, one that knows about Wi-Fi, one that doesn't. So that prevents people from modifying their Bluetooth only, you know, buying the cheap device and then buying their own module and installing themselves. But of course that complicates production. So what I would normally do, the smarter way, is basically have one piece of firmware that simply checks for the presence of this, and if it's there, it's a Wi-Fi device. If it's not there, it's a Bluetooth device. And or it checks a resistor to see if there's like a pop option, to see, you know, if there's like a jumper that sets the version, or maybe even something in the code, like in the E² prom. There's an E² prom on the second board, or what I'm pretty certain is an E² prom. It's underneath this as well. But of course, this thing doesn't have E² prom. It only has just a flash memory. So it would need that for storing the last used temperature, the Wi-Fi settings, that kind of stuff. And you could, you know, at the factory, pre-program in something that indicates that it is whatever model, whatever version of the model it is. So it'd be interesting to see if someone has the Wi-Fi or the Bluetooth model and they can figure out what this chip is. I'd love to see what would happen if you just install this and see what it does. But anyway, yeah, I'm waffling on. I mean, there's not much exciting about this, and I'm not really going to go any further. I've got to put this all back together. But yeah, I mean, I learned that there was a fan in it, and I learned that they used sort of the dirt cheapest processor. That's another thing I should mention. On that table for this MCU, you scroll over to the right, there's actually some pricing, and this I think is a 48-pin QFP. So that puts this particular part at 5.6 yen, which according to Google is 7 cents. That's a 7-cent processor. So I mean, they went for the cheapest CPU they could possibly find for this thing, which, I mean, it's fine. I mean, it doesn't really need to be super powerful, because it's possible that these Wi-Fi, the Wi-Fi and Bluetooth modules, they have all the integrated stack in them. So a lot of these Wi-Fi modules, especially the ones that are not USB, they don't require a driver stack in the actual processor. They actually can decode frames and all this other stuff. You basically just say, I want to connect to this SSD, here's the password, and it connects, and then you can just send very simple data between the processor and this. So basically it offloads all the complicated stuff into the wireless modules. And so that's probably how they've gotten away with such a simple, dirt cheap microcontroller. I'm kind of intrigued as to where the datasheet for that would be online. I wasn't able to find one, but I mean, it's probably not going to be in English anyway. So anyway, it seems to be well designed, well engineered. I mean, it's definitely not designed for down to a cost. Even though it's a super cheap processor, the rest of the stuff that they've done, shows some decent quality. I'm happy with it, and I suspect it'll probably work quite well for quite a while. It's an interesting way to cook. I'll definitely say that, but I'm not going to turn this into a review. So anyway, hopefully that was interesting, and as always, thanks for watching.